Today's lesson is about numeric vectors. How to express vectors numerically. Vector can be represented numerically. We write the numeric form of a vector in two ways. One is a component form, the other is a unit vector form. The component form of a vector is the ordered pair that describes the change in the x and y values. The vector from O to P is OP equals xy, or we write down column xy, which means from this is O, here's P. Then this is a vector OP. You will go to the right or left. This is a x unit. Then go up, it's a y unit. Which means vector has two parts. One is a horizontal move, the other is a vertical move. That's the reason we call this is a component form. The unit vector form of a vector is described in terms of the base unit vectors I and j. I we call the base unit vector in the x direction, which means on this coordinate plane we have one unit. To the right, we call this is I. And j equals 0, 1 is the base unit vector in the y direction, means go up 1 unit. This is j. So the vector from O to P is OP equals xi plus yj. Let's go to guided practice 1. Write the illustrated vectors in unit vector form, which means you have I, you have j. And a component form, we normally use a column x, y. Let's go to A. This is your starting points. From starting point to the right, then go up. We count 1, 2, 3, 4, 5, 6, 7. So here's a 7. Go 1, 2, 3. That's positive 3. Therefore, for the unit vector form, that will be 7i plus 3j. Or I can write down component form, that's a 7, 3. For B, we only have a horizontal move, we don't have a vertical move, which means that's 0j. This is the starting point. Move to 1, 2, 3, 4, 5, 6, which means negative 6i. So negative 6i. And for the component form, we have negative 6 and 0. For unit vector form, if you have 0j, then you just don't write. The negative 6i, that's the answer. Let's go to D. We have vertical move, we don't have horizontal move. That's why we have 0i plus j, go 1, 2, 3, 4, 5, 6, go up. Therefore, it's a positive 6j. So we will write a component form that's 0, 6. For E, this is your starting point. 1, 2, 3, 4, 5, 6. So it's negative 6. Go 1, 2, 3. so positive 3. Therefore, we have negative 6i plus 3g. Component form, that will be negative 6 and 3. How to figure out magnitude of a vector? This is a definition. Vector v in component and unit vector form, we can write down like this and this. The magnitude of length of v, it will be square root v1 square plus v2 square. Basically, you need to think about Pythagorean theorem, so it's easy for you to remember this formula. You have one leg, that's v1. The other leg is v2. So hypotenuse equals square root v1 square plus v2 square. Now practice 2. Find the length of vector c equals negative 2i minus 4j. Therefore, for this vector c, I can write down that negative 2 square plus negative 4 square. You will get square root of 20. Simplify, that's 2 square root of 5. For b, given v equals AP and magnitude of v equals square root of 73, what's the possible values of p? We will set up magnitude of vector v equals square root 8 square plus p square. So we plug in, get square root of 73 equals square root 64 plus p square. Then we square both sides. You will get 73 equals 64 plus p square. This is a power pattern equation, so we need to isolate p square on one side. Subtract 64 both sides. You will get 9 equals p square. Square root both sides, you will get the p equals plus or minus 3. This will be the solution. Then there is a definition for unit vectors. A unit vector has a magnitude of 1 unit, which means the length of the vector is 1. To find a unit vector parallel to a given vector, divide the vector by its length. Let's go to guided practice 3. Show that vector m equals this is a unit vector. So we need to figure out the magnitude of this m. You will get 3 over 5 square plus 4 over 5 square. Simplify, we got the 9 over 25 plus 16 over 25. So we get 25 over 25 equals 1. Then we finish proving. Because any vector whose magnitude is 1 unit is called a unit vector. For b, find the unit vector of b shown below. Vector b is given geometrically. We need to change into numeric vectors. Therefore, check from starting point. I have 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. Go up 2. That's positive 2. So we have negative 8i plus 2g. The magnitude of vector b equals square root negative 8 square plus 2 square. You will get square root 64 plus 4. That is 68. Then we simplify, you will get 2 square root of 17. The unit vector of B, it will be that B over its length. So we have negative 8i plus 2j over 2 square root of 17. So I need to separate. That is negative 8 over 2 square root of 17 I plus 2 over 2 square root of 17 j. Reduce. You will get negative 4 square root of 17. We know that is 1 over square root of a. We can turn it into square root of a over a. Therefore, I can do negative 4 square root of 17 over 17. Same thing we do on this j. You will get negative 4 square root of 17 over 17 I plus square root of 17 over 17 j. This will be the unit vector of B. Now let's talk about the operation of vectors numerically. If A equals A1, A2, B equals B1, B2, then A plus B equals the sum of the corresponding component, the same to the subtraction. Just find the difference of a corresponding component. For multiplication, if k is any scalar and a vector v, you will get kv equals kv1, kv2, which means this scalar will multiply by the both the horizontal and the vertical component. Let's go to guided practice 4. We want to do the operation 2p minus q plus 1 over 3r. 2p, that means we do 2 times 1, 5, minus negative 2, 4, plus 1 over 3, then negative 3, negative 1. So we do multiplication first. You will get the 2, 10, minus negative 2, 4, plus 1 over 3 multiplied by negative 3, that's negative 1. This will be negative 1 over 3. Then we will do addition or subtraction of the corresponding component. So we have 2 minus negative 2 plus negative 1. 10 minus 4 plus negative 1/3. You will get, this is a 4 minus 1 is a 3. 6 minus 1 over 3, that will be 17 over 3. For B, absolute value means magnitude. But anyway, we need to figure out inside first. So P minus 2Q. P will be 1, 5 minus 2. Here's a negative 2, 4. So we have 1, 5 minus, do the multiplication, we get negative 4, 8. Then we do subtraction. 1 minus negative 4, 5 minus 8. Answer will be 5, negative 3, because negative negative is positive. Now let's talk about the position vector and the displacement vectors. A position vector means a vector that starts at the origin 0, 0. For example, this is a origin. So vector P is a position vector. A displacement vector is a vector between 2 points. It's not get started from origin. To find a displacement vector numerically, subtract the coordinates endpoint minus the starting point. For example, find the displacement vector from these 2 points. What you got to do is endpoint minus the starting point. So we have 7 minus 1 and 1 minus 3 for G. Or you can write down like this. 7 minus 1, 1 minus 3, so that will be 6, negative 2. Now let's go to guided practice 5. ABCD is a parallelogram. Find AB, vector AB. So vector AB equals the end point minus the starting point. This is the ending because they said A to B. Got to use the coordinate of ending point minus the starting point. So we have 6 minus 1 and 5 minus 4. So we get 5, 1. Or you can write down unit vector form 5i plus G. B, find CD. CD, draw like this. Since we know ABCD is a parallelogram, which means the opposite sides are parallel to each other and also are equal to each other in length. In other words, for this parallelogram, we have vector AB equals vector DC. Since I'm looking for vector CD, which means negative vector AB, so we get negative 5, negative 1. This will be answer to B. For C, hence, find the coordinates of D. We know vector CD equals negative 5, negative 1, which means we suppose have a coordinate for D that is X, Y. We need to subtract the starting point, that's a 4 and a negative 1. So we get X minus 4, here's Y plus 1. Then check this, negative 5X minus 4. Negative 1, that's Y plus 1. So we set up negative 5 equals X minus 4. Negative 1 equals Y plus 1. From here, we get the X equals negative 1. From this equation, we got Y equals negative 2. So the coordinate for D will be negative 1, negative 2. Now let's talk about vector in space. The position vector of P in space can be written as this. So here, this is a positive X, positive Y, then it's a positive Z. And also we define this I, G, and K as the base unit vectors in space. So the displacement vectors in space, it can be written as this. Remember, it's an ending point. Subtract starting point. Ending minus starting. Vector AB is called the vector AB, or the position vector of B relative to A. The magnitude of AB, that's the formula. Now let's go to guided practice 6. The following diagram shows the obtuse angled triangle ABC such that AB, so AB is this way, AC is this way. Write down BA. Vector BA equals negative vector AB, which means just opposite of each component. We have 3, 0, 4. How to find the BC? For BC, you can go from B to A, then add AC. For vector BA, we already got 3, 0, 4. Add vector AC, that's negative 2 to negative 6. So we get 1, 2, negative 2. For number 3, find the absolute value of BC, which means magnitude of vector BC. According to the formula, we have 1 square plus 2 square plus negative 2 square. You will get square root of 9. That equals 3. Now let's talk about parallel and collinear vectors. Vectors are parallel when they have the same direction or opposite directions. Numerically, vectors are parallel if and only if they are scalar multiples of each other. For example, if vector AB, vector CD are parallel, I can write down vector AB equals K times vector CD. And also, if we have vector AB equals K times vector CD, we can get vector AB parallel to vector CD. AB and C are collinear. That means on the same line. Vector AB equals K times vector BC for some scalar K. Let's go to guided practice 7. Question 1. Vector A and B are parallel. Find R and S. Which means I can write down B equals K times A. So we have negative 6 RS equals 2K, negative 1K, 3K. So we get negative 6 equals 2K. We figure out K equals negative 3. Then we plug in. You will get negative 6, 3, and negative 9, which means this R equals 3 s equals negative 9. So we write down r equals 3 and s equals negative 9. For number 2, what can be deduced from the following? Normally you will say, are they parallel? Are they equal to each other in size? Or are they opposite? So for A, vector AB equals 3 times vector CD. We can draw the conclusion vector AB parallel to vector CD. And second, that's the same direction. Third, that's a size AB equals 3 times the magnitude of a vector CD. Now let's go to B. From B, first of all, we know these two vectors parallel to each other. Second, since we have negative 1/2, which means it's opposite direction. Third, that's the magnitude of vector RS equals 1/2 magnitude of a vector KL. For C, I have AB and BC, which means collinear. For number 3, we have ABC are collinear. Find A and B. If they are collinear, I can write down vector AB. Vector, here's BC. It will be K multiplied by vector BC. So for vector AB, remember it's always ending minus starting. So we have 11 minus 2, negative 9 minus negative 3, and 7 minus 4. So we get 9, negative 6, and 3. Then equals, here's K times BC. C minus B. 13 minus 11, that will be negative 24. And then it's A minus 9, that's plus 9. B minus 7. So every component you multiply by K, you will get negative 24K. A plus 9 times K, and B minus 7 times K, like that. Then the corresponding component equal to each other, we set up 9 equals negative 24K. Negative 6 equals A plus 9 times K. And also 3 equals B minus 7 times K. From the first equation, we can figure out the K equals 9 over negative 24. That's negative 3 over 8. Then we plug into the second one for K. We will figure out A equals 7, B equals negative 1.